So, to practice Coriolis force and centrifugal force, we will do some more problems, and the first problem of today is this: a horizontal circular disc of radius capital R is made to rotate about its axis with a constant angular velocity omega as shown in the figure. So, it is going clockwise as seen by us, and you can work out that if this is x, this is y, z axis has to be coming out of the board, and therefore, this will be omega in negative z direction. A straight groove is made on the disc at a distance x from the center. So, this is a groove. In last lecture I had done a problem where the groove was passing through the center, and now the groove is at some distance from the center, that is the only difference. At a distance x from the center, a small block of mass m is kept in the groove at a distance b from the center and is released from there and is released from there, okay, in the disc frame. So, we have to work in the disc frame, find the distance and the velocity of the block as a function of time at time t, and then find the normal force by the vertical surface of the groove at time t. So, very close to the problem that we had solved earlier. So, if at time t it is somewhere here, let us say, and this y coordinate is y here, y coordinate is here, and the x coordinate is fixed, the x coordinate is capital X, and then we can write the forces on this block that we have to take care. One is centrifugal force, and that is equal to minus m omega cross r, and omega is minus omega k cap, because it is going clockwise as seen from the positive z side. This is omega. R vector at time t you can write as capital X I and plus small y j. Okay. Small y is variable, as a function of time this will increase, capital X will be fixed. So, this is R. So, you can write this as equal to minus m, and this omega vector is minus omega k cap, and then cross this omega is again minus omega k cap, cross r vector is capital X I cap and plus y j cap. And then you first evaluate this. This is m omega k cap cross. Now, here this is minus omega x. So, minus omega capital X, k cap cross I cap will be j cap. So, it is j cap I j k. So, k cross I will be j. So, it is this, then minus omega y and k cap cross j cap, k cap cross j cap is minus I cap. So, this is minus I cap. So, you can make it plus here, I cap times I cap here, okay, and then do this cross product. What is this? M omega square x, m omega square x, that is this, and then we have a minus sign here, and k cap cross j cap I j k, k cap cross j cap is minus of I cap. So, this will be I cap here, one minus here and one minus coming from there. Then here it is plus m omega square y and k cap cross I cap is j cap. So, it is this. We could have written it directly also. The centrifugal force is m omega square and the distance from the rotation axis outward. So, if in this figure the centrifugal force must be in this direction, and that is m times this omega square times this distance and in this direction. So, you can easily write this expression. So, this is centrifugal force. Then you have Coriolis force. Coriolis force. What is Coriolis force? It is minus 2 m omega cross velocity. So, that is minus 2 m, then minus omega k cap and cross velocity. Velocity is only in y direction, nothing in x direction. It can only move in the group. So, it is just y dot. You can write that as y dot or dy dt, and in j cap direction. This rate of change of y gives you the speed, and then j cap direction, and once again this minus and this minus is plus. So, 2 m omega y dot, and then k cap cross j cap is minus I cap. So, it is minus here and I cap here. So, that is the Coriolis force. So, you have Coriolis force in the x direction, velocity is in this direction. So, Coriolis force is just this much, which is in x direction, and the centrifugal force has both components, x component and y component, and therefore, if it is to go only in y direction, x direction there is no acceleration. So, the force in x direction should be 0, right. So, you have yet another force, and that is normal force, that will balance it. Okay. You have Coriolis force I component, you have centrifugal force I component. So, there is an I component, and that I component has to be balanced, it has to be balanced, and therefore, another force, that normal force is there n, and this n could be from this side or this side. The inner side will exert a normal force in the positive x direction, the outer side will exert force in the negative x direction. So, what is the resultant, that we do not know. So, we will just write n is equal to n I cap. It is either this n can be positive or negative. So, it can be in positive I direction or it can be in negative I direction. All right. So, part 1, first part, find the distance and velocity of the block at time t. So, I need y and I need y dot. Okay. So, the force in y direction, let us see force in y direction, that comes from here. So, this is m times omega square y, and therefore, acceleration y double dot is equal to omega square y. We have already solved this equation in the previous lecture. Y is some a e to the power omega t and plus e to the power minus omega t. Okay. Using the initial conditions. What are the initial conditions? At t equal to 0, y should be equal to b and y dot should be equal to 0, that is the condition. Our general solution would be a, and this a also I know, this a is b by 2, Our general solution is a omega t plus b e power minus omega t, but when you put these conditions you get this as y, and then y dot you can differentiate. So, b by 2 and omega will be there, e power omega t and minus e power minus omega t. So, that is the velocity in y direction. That is part A. Now, come to part B. In x direction the total force has to be 0. So, let us collect all the x components. So, from centrifugal force I have m times omega square x, capital X, that is in I cap direction. From Coriolis force I have minus 2m omega, and then y dot that is in x direction, and plus n. That should be equal to 0, and therefore n should be equal to 2m omega y dot, and y dot is here, which is b omega by 2, and then e to the power omega t, and minus e to the power minus omega t. This is y dot. So, this comes from the Coriolis force. N is equal to, this goes on the other side and becomes plus 2 m omega, this is 2 m omega, and y dot is b omega by 2, and this much. So, it is, and from here it is minus m and then omega square n times x. So, that is the equation, you can cancel this 2 here, this omega can be put here, omega square, and you can make some decoration, some simplification looking, and this is the normal force. Now, the thing is that this y dot is increasing continuously. This y dot is increasing continuously. To start with, at t equal to 0, this y dot is 0, and therefore, n will be just this much, and which is negative. The x, this normal contact force is in negative x direction. That means this outer wall is pushing it more than the inner wall. But then this y dot is increasing. It is increasing. Initially it was 0, but then it is increasing, and it may become equal to this, in which case the normal force will be 0, and after that this will be further increasing, and this may become positive. So, that means to start with, you have this outer wall which is pushing it more than the inner wall, and the things can reverse after some time. So, I have plotted this function as a function of time. I had taken some arbitrary m equal to 1, omega equal to 1, etc., b, some values I had taken, and then for various values of t, I have calculated this to see how it varies with time, and that is in the shape of a graph, and that graph I am showing you, and I am describing what this graph is. So, I am showing you 3 graphs. In fact, the first graph which is on your screen is position as a function of time, that means y as a function of time. You have the expression on the board, and then if you plot that as a function of time for a specific choice of omega and b and all those things, this is the kind of graph. It is increasing. To start with, this is 2, b equal to 2 you can take, and then it increases, and it increases. This is the position as a function of time. Then we have another graph. This is another graph which is velocity as a function of time, looks quite similar, e to the power omega t plus e to the power minus omega t, and e to the power omega t minus e to the power minus omega t. Qualitatively they look very similar, because that e to the power minus omega t, that becomes very small. So, whether you add it or you subtract it does not make much of difference after some time. So, that is velocity as a function of t, and more interesting is the normal force as a function of t. The normal force as a function of t, look at it very carefully and see where is the 0 on this vertical scale. See where is the 0 on the vertical scale. So, initially when t equal to 0, 1, 2, 3, 4, you can see from this graph is this normal force is negative, the outer wall is pushing more, but after some time, some 4.4 second or so, n becomes positive. So, there is a point, there is a time when both sides are pushing equally, that means probably none of the two sides are pushing, the resultant is 0, and then after that this inner wall is pushing more than the outer wall and so on. So, that is the kind of variation you have in n. Here is another problem. It says a horizontal circular disc is rotating about its axis with a uniform angular velocity omega in vertical direction, vertically upward direction. A small coin is placed at a comma 0, these are xy coordinates, and is released from rest with reference to the coordinate axis shown in the figure. Find the position of the particle as a function of time and sketch the path. So, here are the axes, you have this circular disc and going about this vertical axis, the disc itself is horizontal and you have x axis and y axis fixed on the disc, and we have to solve everything from the disc frame. We have to sketch the path of the particle with reference to these axes only, everything is to be done in this axis. Now, you remember this was the live demo that I gave. We had a circular disc and then it was rotating about a vertical axis, and then we put a small black ring there on the disc somewhere, released from rest, and then we saw the path. So, that is what we are trying to do the theory. Okay. So, in the disc frame, what are the forces? And the vertical normal reaction of the platform is balanced by the weight of that coin, and friction we are neglecting. So, the only forces are pseudo forces in the horizontal plane. And what are those? The forces. So, from the disc frame. So, we are working with the disc frame only. So, from the disc frame, the force, net force is just the pseudo forces, and that we have m omega square and then r. This is the centrifugal force omega vector cross r, and you know, once it is axis is known, then distance from the origin m into omega square into that distance in the outward direction. So, from the center is just this r vector, centrifugal force, and then you have Coriolis force, and Coriolis force is 2 m omega cross v. Okay, so this we write as m omega square x I cap plus y j cap. I am writing at a general time t. So, if the coordinates of the particle, position of the particle on the disc is x comma y with reference to the axis shown, then this position vector r is x I cap plus y j cap, and minus 2 m omega is omega k cap, this omega vector is omega k cap, and cross velocity, velocity will be x dot I cap plus y dot j cap, the x component of velocity and y component of velocity. So, this is m omega square x I cap plus y j cap, and then minus 2 m omega into omega you can write here, and then okay, 2 m omega x dot and k cross I is j. So, j cap here. The first term I am writing minus 2 m omega k cap cross x dot I cap, this I am writing. So, minus 2 m omega x dot, and then this is j cap. Second term is minus 2 m omega and y dot, and then k cap cross j cap is minus I cap. So, it is plus here and I cap here. So, this is the total force. Remember, we are using the rotating frame. This force does not exist in reality, but if I use these forces, I can use Newton's second law. I can write this force is equal to mass times acceleration, right. So, mass times acceleration is this. This is mass times acceleration, and which is m x double dot I cap plus m y double dot j cap. So, this is m x double dot I cap and plus y double dot j cap, and let us write the x component from the both sides and y component from the both sides. So, you will have two equations. What are those? M cancels out from everywhere. So, m I am not writing, m cancels out from everywhere. X double dot is equal to I cap only, omega square x I cap. So, omega square x here, and then I cap here. So, plus 2 times omega y dot. So, that is x double dot, then y double dot, the y component of the acceleration as seen from the disk frame, j cap. So, omega square y, and then j cap is here minus 2 omega x dot. These are the two equations. You have acceleration in x direction, d2x dt square, and here you have x, that is okay. But here you have this y dot. So, this is d2x dt square, and here it is dy dt. So, how will you integrate? And similar the situation here, this is d2y dt square, but then here you have dx dt. How will you integrate? But there is a beautiful technique for doing that, and that is you multiply this equation by I. What is this I? This I is square root of minus 1. It is not I cap, it is just I, which is square root of minus 1, and then add these two, x double dot plus y double dot, x double dot plus I times y double dot is equal to, here omega square x plus iy, x plus iy, and here 2 omega. Let us take minus 2 omega common, we are adding. So, x dot here, and then minus omega is taken. So, y dot I times y dot here. Okay, so let us check. I have to multiply this whole equation by I. So, this I have put I here, then this I have put I here, and here 2 omega y dot and minus x dot I, all right. So, this I comes here, correct. So, we are adding minus 2 omega x dot I minus 2 omega x dot I, then here it is plus 2 omega y dot plus 2 omega y dot. Take one more I common here, take this I outside, what will happen? What will happen? This will be omega square x plus iy minus 2 I omega. I have taken this I also outside, and this becomes x dot plus iy dot. Okay, I into I is minus 1. So, that plus becomes minus, and I if goes here it will be I x dot. So, this is it. Now, define q, which is x plus iy. Let us define this quantity q, which is x plus iy, and then it is q double dot equal to omega square q here minus 2 I omega here, and this is q here. So, now I have an equation in q as a function of time. So, I can bring this side, q double dot plus 2 I omega cube and then minus omega square q equal to 0. And this is a very standard second order differential equation with constant coefficients. You have second derivative q double dot. Q double dot is what? Q double dot is dq, d2q dt square, and then plus 2I omega, and then q dot, this is q dot, this is q dot, where is q dot, x dot, y dot. So, minus 2I omega q dot here, and this is q dot here. So, dq dt. So, dq dt here, and then minus omega square. So, this is plus I omega square and q, and this is equal to 0. Okay. So, it is a very standard equation. Though in textbooks of differential equations, you will find this d2y dx square plus c1 times dy dx plus c2 times y equal to 0. This is a standard statement of the differential equations of second order differential equation with constant coefficients. That is the heading. And the rule is that you write y as e to the power alpha t and put it here. If you put it here, and then you get second derivative. So, alpha square e to the power alpha t plus c1 into first derivative. So, alpha times e power alpha t, then plus c2, and simply e to the power alpha t is equal to 0, and that gives you alpha square plus c1 alpha plus c2 equal to 0. Then this is a quadratic equation. You will get two values of alpha, say alpha 1 and alpha 2. Now, if alpha 1 is not equal to alpha 2, then your solutions are y is equal to, this is all x, this I have written x here. So, let us write x here, all right. So, x here, x here. So, your solutions are y is some constant, arbitrary constant, e to the power alpha x, that is alpha 1 x, plus another constant e to the power alpha 2 x. This is the final general solutions. You have second order equation, you have two arbitrary constants, done. But if alpha 1 is equal to alpha 2, that happens when your discriminant is 0 and all that. If that happens, then the rules are different. Then y is equal to a plus bx and then e power alpha x, whatever that, alpha 1 is equal to alpha 2. So, both are equal, any one you put here. So, this is the rule, remember this is the rule, and according to this rule I have to solve this equation. So, let me make some space here to work. So, let us do this. What we will do, we will be putting q equal to e to the power t here. So, alpha t. So, d2q dt square. So, alpha square e to the power alpha t. So, this will be, let us say, let me do here, alpha square e to the power alpha t. This is this part, plus 2 I omega and then dq dt. dq dt will be alpha times e power alpha t. So, alpha times e to the power alpha t, and then plus I omega whole square. So, plus I omega whole square, and q is e power alpha t, and that is equal to 0. So, this is equal to 0, and it gives me alpha square plus 2 times I omega times alpha plus I omega square equal to 0. And that means alpha is equal to alpha plus I omega whole square is equal to 0. So, alpha is equal to I omega comma I omega. Okay. So, the two roots of this quadratic equation are equal, and therefore, I have to use this recipe. My general solution will be q is equal to some arbitrary constant capital A plus bx, so plus bt, and then e to the power alpha t I omega t minus I omega and minus I omega. Okay. So, minus I omega t. What are these arbitrary constants capital A and capital B, and how do we get it? From the initial conditions. If this is q, dq dt will be you have t here, you have t here. So, I put this thing here, I differentiate this. So, I get to b, and I put just e power minus I omega t here, and then I keep this a plus bt intact and differentiate this minus I omega and then e power minus I omega t. Okay. Q dot differentiation with respect to time. So, two factors, one factor is here, another factor is here. So, first I keep this factor intact and differentiate this factor, and then I keep this factor intact and differentiate this factor. So, minus I omega e power minus I omega t, this is our q dot. So, let us say what happens at t equal to 0. At t equal to 0, we have released the particle from a comma 0 on this xy plane. Okay. So, x is equal to a, y is equal to 0, therefore, x plus I y is equal to a, and therefore, q is equal to a. At t equal to 0, q is equal to small a. So, use this thing here, small a is equal to t equal to 0. So, t is equal to 0, this factor is gone, capital A into e power minus I omega t, t is equal to 0. So, e to the power 0 is 1. So, just a, capital A is same as small a. We released this coin from this point a comma 0, and that tells me that this capital A is nothing but a. Then what is q dot at t equal to 0? At t equal to 0, x dot is 0, y dot is 0, and therefore, q dot is 0, released from there. So, q dot is 0 and here is q dot, and at t equal to 0 this should be 0. So, this tells me that 0 is equal to t is 0. So, it is b plus a plus bt, this t is 0. So, it is a plus a, and then here minus I omega, this minus I omega, t equal to 0. So, this factor is 1, right. So, once again at t equal to 0, no speed. So, x dot is 0, y dot is 0. So, q dot, which is x dot plus I y dot, is 0. So, that is why this is 0 here, and here t equal to 0. So, t equal to 0, this is 1. So, capital B plus t equal to 0. So, this is capital A. So, this is capital A, this is 1. So, it is minus I omega, and this tells me that B is equal to I omega A. So, B is equal to I omega A. I know now what is A and what is B. This is I omega small a. Finally, Q is equal to A is small a plus B. B is I omega A. So, I omega A and into t. So, this is t here, and then e to the power, then this whole thing e to the power minus I omega t. So, this is q. What next? Write this q as x plus I y, and then compare the real part this side, real part this side, imaginary part this side, imaginary part this side, and that will give me x as a function of t and y as a function of t. So, we will continue from here. Next lecture we will complete it and go to the next topic.